Hello everyone. Am I audible?
Yeah, yeah.
Yes, yes, yes.
Uh, okay. I'm Sami Ahmed and I'm a core member of Atom Robotics Lab. We are developer committee based out of Mid Delhi and our current focus is on developing a culture for robotics in the city. We have been in operation for about 1.5 years now and we are excited to be here today for the Townhall event for our Mr. Robot project. Okay, so anybody have a slight idea about what Mr. Robot is? Anyone? You can unmute yourself and speak.
A mobile robot.
Okay, so basically it's an AMR that is versatile and adaptable to be various tasks. Now I will hand over to Krish and Alok who will be presenting to you our Mr. Robot. Okay, Krish.
Thank
Thank
you,
you, Sam.
Saim.
So my name is Trish. So today I'm going to present our community base major project called Mr. Robot. So start with it. What is Mr. Robot? When we first come to college and we find everyone doing some basic project, basic day-to-day tasks, basic making some basic line follower code, some object detection bot. These are some basic tasks doing robot. So to overcome that, we develop some robot called Mr. Robot. So that we can basically uh, integrate all our application into it. So what I mean to say, Mr. Robot basically provide various application. You can plug and play anything you want. If you want to basically attach an arm onto it, attach any camera on it, you can do that. So basically it's a basic AMR platform on which we are implementing our various application. So everybody I think know about the AMR also. Uh, if not, I would say basically AMR is an autonomous mobile robot, which basically perform which basically navigate in environment without any human interaction, with the avoiding all obstacle and creating its own path. So that's the basic our idea of our Mr. Robot. Like so, start with it. This is our basic project process we have implemented till now. Uh, we had designed our CAD for that first, then fabricate, and then start working on simulation. So, CAD for that, we also take in many criteria. We had divided our bot into layer-wise system so that we can avoid using large spaces. Cause in navigation bot, we usually prefer a compact one so that it can basically navigate to anywhere. So we basically provide a layer system in it. Like you can see there, we for layer one, we basically provide for battery and all the motor component. And the second layer, we basically for the all main processor controller part. And then top layer, we basically provide for any our attachment basically, which can be either any camera, any arm, or anything else. So after that, come to our basic structure of all navigation and the our basic our main AMR part. This is our basic structure of our AMR part. So you can see there is a basic main processor Raspberry Pi, which basically communicating through LiDAR and using body LiDAR node, and it also calculating the motor encoder so that it can basically uh, so that it can basically check its odom Using that only, we can like basically check whether where is our bot is, like to check it orientation and everything. And after that, we basically or push all and we basically give all data to navigation stack so that it can perform all the navigation tasks. So come to next slide. This is our basic navigation. This how like navigation work. Basic main. Like first we like develop a map for our environment. So that basically in any navigation system in initial stage, we just need some kind of map so that you can basically provide so that basically it can find the optimal path. Like
Uh,
in yes.
Actually, we have mentioned Z mapping. There are different type of mapping algorithms also available. We have mentioned Z mapping because we are using Z mapping in our project. Z mapping involves all the odometry that we calculate and accordingly maps. There are different type of mapping algorithms also like Hector Slam and Cartographer. They don't require any odom. Basically, you can just hand lidar on your hand and just walk around the park. It will map accordingly without having any odometry data. Odometry is basically the location of the bot in the real world with respect to the with respect to the frame. Krish, continue.
Okay. So like the Alok said, like come to AMCL. What AMCL is like when we like basically create our map in our for basic path planning. After that, we basically what we do we launched AMCL node so that basically it orientate the laser scan like current laser scan with the map we had provided, which help basically to like orientate bot itself according to the map. And move base, basically this is the main part for the navigation system, which basically control all the how like how much twist value we need to give to CMDL, and which basically like take all the message and give it to according to it.
Moobase also handles all the planning algorithms. There are two types of there are four parts of Moobase. Krish, can you shift back to the previous slide? Yeah, Moobase has four parts. One is global planner, local planner, global cost map, and local cost map. Global cost map is basically that part in which the bot has already been to that place and has the data stored in it. Basically, they it consists of all the static parts like walls and etc. Recorded, and the local map is dynamic in nature. Basically, it changes as we come in front of it, and it avoids us. Like it's basically used for object avoidance and all. We use local planner, and for the other part there are two types of planners, global planner and local planner. Global planner what does is it's create a shortest path between the points that we have given. It uses mostly two type of algorithm, or you can implement your own algorithm also. One is A star and the other is Dextro. And the local planner is basically the uh, works with the local cost map and develops a small path in which the bot would take its turn. The basic local planner is DWA planner that we use in our project. Krish, continue.
So this is the navigation stack we are talking about. So this consists of like all the basic part, which like basically how they communicate to each other. Like you can see AMCL, which basically like help in like basically TF what it is. You can see like in CAD also. If we talk about CAD, what uh, we basically get from CAD, basically we get the all the transform from all the link we needed. So after the transform we get, we basically give it to navigation this move based planner, which help in basically calculating all the how we should like how it should move the board to avoid any collision within area. So this is like all that we also like perform. We can also perform like this recovery behavior in this. So like to avoid this unnecessary you can say uh, uh,
Basically, when the bot got lost in its own, so recovery behavior is basically the bot takes a 360-degree turn and see its surrounding and relocate itself where it is actually in the odom.
yes. So this is like how navigation stack work, and then it basically like this sensor topic, like lidar you can say, or it take data from it. So this is the navigation stack, and this is the simulation setup we have done already. Uh, you can see like we just pointing the goal in it, and it will navigate through it. Uh, after like done with the all simulation part and navigation implementation, we start with building our hardware part. So we implement our basic structure, which we like using ESP as a controller for motor controller, and we like basically done all the use this and this, and this is the like our basic approach we implementing right now. You can see the Kinet on it. We try to implement this like attaching or everything on it, but like a slot-based system. We like basically uh, implement aluminum extrusion on it on the surface of board so that it can easily slide to it and it can attach. This is also like our idea of implementing in future. Like if we want to put arm on it on our as attachment on it, we can implement it. This is the laser scan demo we have done. In this, like we have also done the sensor fusion in it, because initially we are implementing our navigation stack using ODOM from wheel for motor encoder only. But after facing some issue on it, we start implementing using sensor fusion. We basically what we do, we use IMU sensor, which is a 6-degree freedom sensor, which can basically uh, give our which basically give pose and orientation of any object. So we what we do is like we fuse all the odom data from the sensor into the wheel odometry we have already have, which all we have already have, and also we, like from laser scan AMCL one we have I have told already. We basically what we doing a precise local robot localization we are performing here, so that it can like if we like move bot from here to there without any like from we like from अगर हम हाथ से पकड़ के ऐसे like if we move from bot here to there, it will like automatically localize itself using IMU and AMCL. Like we don't depend only on one odometry resource, we depend on three resources basically. So here is an example of mapping here. We are currently performing mapping of our lab. And this is the navigation stack we had also implemented on it. You can see. So
Basically, what
basically
is
what
hap-
we uh,
Okay, okay.
so basically what we have shown here, like basic like first we give the global path here. It basically goes to the path, but between there is some like some person, so it basically avoid it, and this come under our local map part, in which it avoid all the part and goes to our main target location. So this is
सुन
the
उसके आगे चला जा कहीं पे उसके आगे चला जा
this is like our progress right now. We are like implemented our navigation stack till now on board, and hardware part is also done. And currently also like we are initially like you can see we had built our bot uh, on this like this, and now we are like thinking to like uh, goes to the one more step further, like to implement this hardware into aluminum extrusion so that it can be like little bit more sturdy. And after that we like start implementing this plug and play part on hardware. So that's from my side. Any query?
Okay, so let me give a short demo of the simulation. Please, everyone, join my screen. So basically, what I'm doing is launching the gazebo file, and it's the Turtle Boss bot house. Shout out to Rig Beetle Labs for providing this uh, playground to us for testing of our bot. And you can see what now I'll be doing is launching the navigation stack for the bot. So what you can see is this is the map that we have mapped for this playground, and I'm providing a 2D nav goal for this. You can see this red dot points. Basically, it's pointing towards the laser scan of the bot, and now you can see bot has reached its destination. We can also check the AMCL also by moving the bot somewhere in this playground space. So what is happening is this clustering of point arrays happening, and it's relocating the bot by the laser scan that is being provided to it. The teleportation of the bot is happening in the visualizer so that it can get to the correct location, precise location of the bot. See, it's now reaching the correct position. So that's how AMCL works. Thank you, Krish.
So any related to this?
So yeah, that was a pretty good explanation, Krish and Alok, on our major project, Mr. Robot. I would request the people who have joined, if there are any queries on your part about any tech stack that you might have not understood during the presentation, or anything else you want to ask about, please share. So I guess that was all clear. So this was first town hall event for the project Mr. Robot. We'll be hosting these events bi-weekly on Saturdays at 5 p.m. You all can join in the further events and get and get a weekly or bi-weekly update on what is being developed on the core side of the project, and also can contribute towards the project. We'll be opening GitHub issues, and we'll also have people who can join us and help us during the development of the project. So yeah, that was all at our part. We have some new members. I can see 4 to 5 members who have joined from outside the organization. Would you like to introduce yourselves? I can see Gurkirat, and there is someone with the username Zeus D something and Abhai something. So would you like to introduce yourself, guys?
Hello,
Hi, Gurkirat.
hello everyone. I'm Vikirat. I'm from Mohali, Punjab, and I'm currently pursuing my degree in mechatronics. And also, I was working on Turtlebot 4, so I wanted to attend this lecture. I have a doubt. You guys are using kinetic for visual mapping, right?
You mean Connect?
Yes, like we are implementing or done the like optomapping using that.
You can
We bas-
also have you can also do mapping using Kinect. There is basically a package, ROS package for like using the IR sensor of that Kinect for mapping,
Okay.
and you can also perform 3D mapping like octo mapping and ARTA mapping for the same.
What was the question? Okay.
So I don't know about these things, but the thing is, I have this minor project for this semester. It is basically for 3D visual mapping using Octi Pro camera and Turtlebot 4. So I was not clear about the topic, what I need to search for, and how to proceed it. So can you please guide me a little bit?
Yeah, Gurkirat, I'll help you on this. Right now, for our project, we are using a Kinect for the 3D mapping part. The IR sensors inbuilt in Kinect provide us with IR sensors along with the depth sensor provide us with the 3D visualization of the arena. And yeah, we do the we perform atom mapping and octo mapping using the Kinect sensor. There is a ready-made package available for the Kinect sensor with ROS. So right now we are using that. You can also you can research around the sensor that you might be using with the project.
You can also find the implementation on our GitHub also for Mr.Robot. You can check out the perception branch for the same.
Okay, thank you.
Any other question?
Okay then, guys. Thank you for joining us. So we'll be having some more sessions later down the road. This was our first session about the Mr. Robot, where we had the general discussion about it. Maybe we can dwell into the details about how the stack is we are using, and maybe about some other resources we can provide later down.